Hi everyone. This is Dr. Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology. This is unit number 5, Operational Amplifier and Timer IZ. And let me see a 1 DAC techniques, digital to analog conversion techniques, weighted sum. Weighted sum. You mean an operational amplifier acted as a summing amplifier which converts digital into analog signal Yes, this is a digital to analog conversion. Data in a clean binary digital form is easily converted into analog with the help of a summing amplifier. You mean operational amplifier acting as a summing amplifier, summer. Let me consider a 4-bit DAC converter. A 4-bit DAC converter. See here the diagram shows a DAC in blue color where the 4-bit is a 4-bit digital input and it is converted into an analog signal, a waveform analog signal. Weighted summing amplifier. This is the circuit diagram of a simple weighted sum DAC, a weighted sum DAC. The triangle indicates an operational amplifier where the non-inverting input plus is given to a 1 ohm resistance, 1K resistance to a ground. Whereas the negative input, you mean an inverting input, a force supply, inverting input is given to a supply. You mean there are 4 bits. One is VA, another one is VB, VC, and VD. Therefore, the 4 inputs is connected through a resistor is given to the inverting input terminal, The triangle represents operational amplifier, positive terminal input represents non-inverting input which is grounded, and negative, you mean inverting input terminal is given to 4 resistors and 4 inputs, you mean VA, VB, VC and VD. The 4 resistors values is not equal. See the circuit diagram, it is not equal. It is one is 10 kilo ohm resistance, which is R1, which is nothing but R1. 10 kilo ohm resistance, which is nothing but R1. And the second one is 5 kilo ohm resistance, which is R2. 2.5 kilo ohm resistance, which is R3. And 1.25 kilo ohm resistance, which is R4. Therefore, for 4 bits, 4 values of resistor is required for the summing amplifier as an input. And the feedback resistance is 10 kilo ohms, which is RF, which is connected in between the output terminal and the inverting input terminal, RF. Now this is the weighted sum DAC circuit. And for this weighted sum, you mean the summing amplifier, you have already know that the output voltage Vout is given as R is given as minus of RF, you mean the feedback resistance, RF by R4 into VD plus RF by R3 into VC plus RF by R2 into VB plus RF by R1 into VA. This is we already derived from the summing amplifier circuit. This is the output voltage. Now the feedback resistance is 10 kilo ohms, whereas the resistance R1 to R4 is a variable resistance of one is 10K, 5K, 2.5K and 1.25K. Therefore, why this this variable values of resistance is chosen, since we have to convert digital value into analog value. Now let me see an example. Yes. See here the example, 1101. 1101 is the input. 1101 is the input. The example is 1101. You mean VD is MSB and V is LSB. Least significant bit is VA and most significant bit is VD. Therefore, 1101 is the digital input which is given. Now substitute this 1101. You mean when it is 1, VD is, there is an input in VD. And another one, VC, there is an input. Whereas in VB, there is no input. It is 0. And VA, there is an input. Right? You mean 1 means it is plus VCC and 0 means it is ground. Again, I'm repeating, 1 means plus VCC, the supply is given, and 0 means it is ground. There is no pulse. It is ground. Therefore, you have to substitute as a summing amplifier. This is 1.25. You mean RF is 10. 10 divided by 10 in VA, which is nothing but 1. And 5 divided by 10 in VB, which is nothing but 2. And 2.5 divided by, 10 divided by 2.5, which is 4. And 10 divided by 1.25, which is